All right, let's get started. This talk is called Parasitic Programming Languages. This talk could have easily been titled Symbiotic Programming Languages, but I thought parasitic sounded a little bit grosser. Maybe more people would be intrigued. But basically, this is kind of a fun talk. It's sort of for people who are interested in programming languages, but if maybe you're looking for a more productive programming language, this talk is kind of about a trend that's been going on for about a decade with respect to new programming language development. And maybe it'll give you some ideas, because I think the risk assessment can be quite different now based on this new trend, which is that there are programming languages which are being created which are not trying to reinvent the world. They're not trying to start from scratch. I mean, you have cases like this, like Swift and Rust, but I think there's a stronger trend around parasitic programming languages. And you can make a very different risk assessment. These languages often are designed to work very well with some mainstream ecosystem. A little bit about myself. My name is David Nolen again. I'm a software engineer at Cognitect. Cognitect is the steward of the Clojure programming language, which is a dynamic functional Lisp for the Java virtual machine. It's pretty cool. We also steward ClojureScript, which is a dialect of Clojure that compiles to JavaScript, which is also really cool. I'm the lead developer of that project. Until recently, I was also working on Datomic. And Datomic is a functional relational database, which is a great fit if you buy into the functional mindset. So Cognitect is a sort of a software consultancy, and really, as a core value, we sort of, if you've seen Rich Hickey's really awesome talks on simplicity, we believe that we can build much simpler software systems. There are, of course, competing opinions about how to get there, but at Cognitect, we embrace functional programming and immutability, and our clients seem to agree with us. We can build a more reliable software faster using these techniques. So this talk is about a few programming languages. I'm going to spend the most time on the ones I'm most familiar with, because I've contributed to Clojure and ClojureScript. But I will sort of do a very quick survey of some of the other things which I think are interesting. Programming languages are an interesting topic because they really sit in a funny place in the software industry, right? Because if you asked a programmer, you ask them, do you think do you think the choice of the programming language is important? And I think most programmers would say yes. Having been in the industry for a while and seen many projects fail, I would say the choice of the programming language doesn't really matter as much as people want them to matter. And in fact, I don't believe in the thing that people often refer to as a software crisis. There's only one crisis in software, and it's about people. Projects fail because of people and processes, and whatever technology stack you pick, it's really not relevant for why your project didn't work out. But programming languages are important. It is the tool, right? We build stuff, and we want to use good tools, and we want to feel good about the work that we do. So the programming language choice does matter to a degree. It also matters, if you're working in a very specific domain. You want to build highly concurrent software. Well, then maybe building it in, Ruby or Python's not the best idea. You have a global interpreter lock, so maybe that's not a good fit for what you want to do. But sometimes things happen in the industry where suddenly something that didn't seem like a good fit actually is a good fit. A case of this is definitely JavaScript and this sort of new trend in serverless programming. If you're writing very simple stateless endpoints, JavaScript is just as good as anything else. But let's dig in a bit here about this specific topic, which is parasitic programming languages. Another issue you often see in the software industry is we suffer from fixed ideas. You often hear people say, you could never build anything with a dynamically typed programming language, or you can't do anything with NoSQL, or you have to use SQL. You hear people say these things, and as I've said, it doesn't, often these statements are made without enough context and generally lacking any truth or verifiability. But the fixed idea is a problem. I really think nature's inspiring here. It's always really fascinating I'm sure many of you went through phases where you're really into nature, and I had my insect phase when I was young, and I was really into spiders for a while. Hopefully this slide isn't totally freaking anybody out. This is a jumping spider. Yeah, little guy, really cute. They don't bite, they're pretty friendly. But this is also a jumping spider. This is I think it's Myrm arachne. So there's about 300 species of jumping spiders that morphologically resemble ants. Because a spider, right? A spider lives in this ecosystem, and in the microcosm world, the spider is the tiger, right? It eats the other bugs. But of course, there are birds and rats and mice and who knows what else that predate on spiders. So spiders need to come up with a solution to this problem. There's many strategies, right? Your blood can be gross and you don't taste very good. But the Myrm arachne genus, I think it's a genus, their strategy is that they look just like the host colony, like whatever species they parasitically embed themselves into, and actually this morphologically precise, right? So there's a black bump on the left, and that's not a real eye. That's a fake bump that looks like the ant eye. It actually has its normal 8 pair of eyes in the front. So this is really amazing. So they use the ant colony to avoid predation, right? So they found a very powerful solution to the problem of predation. So I think nature's very inspiring, this idea of the parasite. You have this extremely powerful sort of system already in place, which is the ant colony, and you can basically take advantage of it and be embedded in it. And I think a lot of, this is about risk sort of management, right? The nature has come up with a really beautiful risk management strategy for this particular species of spider. And I think that parasitic programming languages have the same benefit. They actually have a surprisingly low amount of risk if they're well designed. All right, but in order to set this up, let's go back to 1995 when Sun declared that they were going to, take over the internet with this thing called Java. Further down in this article, there's this funny statement. Sun and Netscape are announcing a new version of Java that is intended to make programming more accessible to non-computer experts. And this is going to be JavaScript, right? So this article was written 22 years ago. 22 years ago. And I'm pretty sure nobody in this room believes that Java or JavaScript are going away. Java is definitely not going away. If anything, JavaScript is only picking up more steam, more traction, and completely taking over everything. It's funny because if you go back even 22 years, like if you go 22 years back from 1995 to 1973, right, it was very unclear that any technology would have this amount of scope or this amount of adoption. So the sort of judgments or decisions that we make in our world, it's very different from what people would have made in the past. And this is sort of beautifully captured by the fact that when MIT stopped using Scheme in their intro programming course, I believe this was 2007, 2008, something like that, about 10 years ago. They stopped doing it, and of course all the functional programming people were like, oh, it's a travesty, But Sussman had a very good point. The realities of software development, very different. Programming, he's talking about how programming isn't like it used to be. Everybody used to write their own thing from scratch. And it's not so much like that. Nowadays, you muck around with incomprehensible or non-existent man pages for software that you don't even know who wrote. Right? This is the outcome of the open source software movement. You have to do basic science in your libraries to see how they work, trying different inputs, seeing how the code reacts. This is fundamentally a different job. And I would argue that this is the truth. You're building an SPA and you hire somebody to build your SPA for you. And what are they going to do? The first thing they're going to do is be like, well, what's the right rendering library for our SPA? What's the right, client-side state library for SPA? What's the right, request library for a thing? So it's really the job of the programmers assessing the existing ecosystem, making the right choices, and then tying them together to solve the problem. It's highly unusual. There's still domains. Of course, there's still domains where people start from scratch, but it's a highly unusual activity now. So this has real repercussions for new programming languages. So I stole this slide from Simon Peyton-Jones. He has a great talk on the history of Haskell. Haskell is a sort of an outlier for academic programming language, and somehow that it survived. Most of them die this extremely quick death because somebody wrote it for their PhD and that's it. It doesn't actually do anything interesting except for maybe they prove some theorems. That's cool, but you can't really use it for anything. But the problem is, the reason, and it's gotten even worse, is because if you make a new programming language, a person's going to ask you, well, what can I do with that? Theoretically, it sounds interesting. But what libraries can I use to solve the problem that I actually have? And you'll be none, because we haven't written the FFI yet. So it's an issue. And so as a language implementer, I think the cost-benefit analysis is very different these days. You have the JVM, the Java Virtual Machine, now has 20 years, or no, more, probably more, but at least 20 years of compiler optimization technology and know-how put into it. So starting on a language project, you're like, should I spend all that time, making my own compiler and optimizing compiler, and am I really going to ever get any better than the stuff that's already out there? And this relates all the way back to Fred Brooks. When Fred Brooks, you wrote the Mythical Man Month, and they were working on the IBM 360, one of the things they had to do was write an Algol compiler for the 360. And he was like, it doesn't matter how many people we hire, I know this will take exactly 6 months to do, right? So that was completely not true. It took way longer than that. When you're starting to do a new programming language, you might decide to just pick an existing technology. There are, of course, trade-offs, right? If you start from scratch, and it's not like I'm saying people shouldn't be doing new programming languages research. People should be. But say your goal is to basically get people to adopt your thing, then you might, and really as quickly as possible, possibly. Maybe you want to get a decent user base in a couple years. Then you might have to do something else. So you have existing VM technology like the JVM. There are trade-offs, right? Because the JVM was designed for one specific programming language, Java, and you may have to make some concessions there. But it may be that given those concessions, you can still make reasonable improvements over the other approach, which is Java, right? You believe that you can provide better semantics on existing compiler technology. And this sounds actually, I would say in the early 2000s, that was a wacky idea. People had said, I don't know, doesn't really seem that interesting. But I think now that we're 10 years in, it's actually not a bad idea. Scala, I think, has had a significant amount of adoption. There's libraries. In fact, there's all these interesting libraries written in Scala that people use from Java. And that works okay. So Scala has shown that it's not a bad approach. And now Scala gets to focus on what? They get to, they got to focus on the problem they were interested in, right? So now that you're not burdened with how are we going to build the software ecosystem and the compiler technology, what's the problem they wanted to solve? They wanted to reconcile sort of what we learned from engineering, which was that object-oriented programming is useful. It is a productive approach, and they wanted to combine it with some of the more theoretical results from functional programming. So bringing these two things together, and Scala was heavily focused on that, and I think they derived a lot of benefit from that. Then you have things like Clojure. Clojure, I would say, was sort of, created by somebody who was doing concurrent C++ software and concurrent Java software, and finally got fed up. And somebody who had, liked Lisp. And so if you look at the design of Clojure, I mean, Clojure is almost a textbook response to Java concurrency in practice. Like you read through it, it's like all these things to avoid all these things you aren't supposed to do, and Clojure checks off all the boxes. Those things aren't possible for the most part in Clojure. So again, Clojure was heavily able to focus a lot, right? So a ton of effort was poured into Clojure, but all that effort was in the design of efficient immutable data structures. Right? And a nice set of concurrency primitives. So a laser focus on getting that right, and that we don't have to worry about creating our own Maven. Of course, there's lots of other interesting languages. Not all of these are new, of course, but you're probably starting to see this is how people are able to mitigate risk, right? So you have things like Groovy. Groovy wants to be more expressive, more amenable to scripting than Java is. Java's not that fun to script with, so Groovy, right? You get to do all the stuff you did in Java, but you get to use a scripting-like language. Ruby, JRuby, right? JRuby is really cool. JRuby is really ambitious because you have the entire vast ecosystem of Ruby, which is, almost more than 20 years old, more than 20 years old, and you got all the resources of Java, and you get to combine both ecosystems into one thing. There's a ton of value there. You have newer efforts like Kotlin, that's from IntelliJ. You have Frege, which is trying to bring sort of a more Haskell-like type system to a language on the JVM that still gets to interoperate. And then you have things like Nashorn, which is Oracle's new JavaScript engine, which is a successor to Rhino. Which brings us to the next topic. So we get a sense, there's a benefit, there's a huge benefit. It's hard to measure around the fact that these languages decide to go with the JVM. There are a lot of things they don't have to worry about. And again, it makes it easy for you to assess. Maybe you have a Java shop and you're like, we can experiment. Let's see if we can be more productive with a different technology. So how much of a risk burden are you taking on with that? Not that much, because all these languages I'm talking about, they work with whatever, Ivy, Maven, all this stuff. All the JVM stuff they're used to, these languages just work with. So a much smaller risk. So going to JavaScript. So JavaScript is, it's hard to tell where JavaScript is going, but definitely there's a lot of parasitic-like programming languages in this space. I'm going to talk first about the more pedestrian ones. For a while, CoffeeScript was kind of popular, though it's less popular these days. But CoffeeScript, I think, did a great job in opening up people's mind to the possibility of source-to-source compilation. It's with the exception of some scoping things, it doesn't really add that much semantically to JavaScript. Then you have TypeScript, which is a more recent thing, and TypeScript is hugely popular, right? Because everybody goes to school for computer science, but what do you learn? You learn Java or C#, right? So TypeScript is a way to get developers to not be afraid of JavaScript, because JavaScript's kind of scary. I mean, they've fixed a lot of things with the newer version of JavaScript, but there are a lot of problems with JavaScript if you want to write more significant programs. But again, TypeScript isn't adding much new here. So, so I want to spend a little bit of time talking about these weird things, right? The spider's kind of weird, and let's talk about some languages with very different semantics from JavaScript that yet integrate quite well with it. So one of these, which is really cool, which has been fun to watch sort of take off, is Elm. So Elm, and I think Elm is particularly interesting because when it was released in 2011, I think, people, even I was scratching my head, but a lot of people were scratching their heads. And I would say now it's very different, largely because of React. So React was sort of an unforeseen event. Nobody could have predicted that React was going to happen. Certainly nobody could predict that React would, achieve escape velocity in record time for a framework. But React sort of opened up mainstream developers' eyes to a functional approach to UI development, right? This is something that everybody would have said that's just bullshit. You can't do functional UIs. There's no such thing. And React said, actually, we can have this very thin object-oriented veneer, but everything about it is sort of functional friendly. And when I saw React, I was like, oh my God, somebody figured this out, a fairly functional friendly approach to doing UI development. And now people are jumping from React to Elm because it's a short leap. It's a short leap now, whereas before there was this conceptual barrier. And now that conceptual barrier has been erased because a lot of people know React and understand it quite well. Elm is also really interesting because I think it probably has the best chances to get people excited about non-nominal type systems because Elm, the type system isn't actually that super expressive, but it's good enough for the type of task that the designers want Elm to be used for. And that means that their error messages are pretty incredible. They're very accurate, they're very precise. And that's a really cool feature. I mean, if you're coming from JavaScript, it's shocking because, in JavaScript, undefined, null is undefined. That's a pretty normal thing. Like what, that's an error. That's a real error message. Null is undefined. I know that. So then you have things like PureScript, and PureScript I think is going to have a little bit more of a hurdle, but it's also trying to bring some of this fancier type-based approach. But at the same time, if you look at PureScript, if you're making a risk assessment of these technologies, right, these parasitic, I work in JavaScript, you can really examine them and see how well do they integrate with JavaScript. PureScript actually went, they doubled down on NPM, and it has a very nice NPM-based package management story. So this means that they're saying, we believe that the NPM ecosystem has more or less won, and we want to decrease the friction there. So you see this is a huge thing with these sort of parasitic languages. Very low friction to integrate with an existing ecosystem, which is already completely, ingrained in the mainstream. Which brings us to ClojureScript. ClojureScript is the thing I know best because that's what I've been working on continuously for about 5 years. ClojureScript is not, it's not of the typed variety, but it's an interesting project. When it came out in 2011, some people were scratching their heads. Well, what is this? What is this doing that is important? And in fact, I hacked on it because I thought it was fun, and it was also unclear to me that it was offering anything significant yet, because you were taking a language that was designed for concurrency and the JVM, and you're saying, okay, well, now we're going to compile a JavaScript which is single-threaded. So what real benefit were you deriving there? And it took a couple of years, and I would argue it took until the appearance of React, right? Because prior to the appearance of React, if you were doing ClojureScript, you were doing ClojureScript plus jQuery or ClojureScript plus Angular. And it was always like pretty yucky because Angular and jQuery, they're very just mutation, right? They're just there's a ton of mutation in that type of code. And then when React appeared, it was like, the light shining down from heaven. Oh my gosh, we can pass purely functional data structures into a React view, and it just works. Not only does it just work, I wrote a very popular blog post 3 years ago, which is the most popular blog post I've ever written in my entire life, which showed that ClojureScript was faster. A naive ClojureScript program using React was faster than a naive React program written in JavaScript because we could use immutable data structures to do very fast equality checks. So if nothing had changed, you could speed up rendering by 2 to 3x, and that was a really cool result. But the point of doing this, right? The point of just saying, well, we're not going to do our own thing. We're just going to compile to an existing thing, is that you get benefits of where the industry is going, right? Nothing is going to happen to browsers, right? When these mobile smartphones came out, it was like, oh, it's the age of the apps. But people are still looking at their web browsers. Web browsers aren't going anywhere. So ClojureScript was a way for, I think Rich was it was a very forward-thinking move to make because they're not going anywhere, and in fact, they're only getting more important. And clients, many clients want to do stuff on the web. And when I say stuff on the web, I mean stuff that uses web browser technology. You might be building an application, and the application is just an intranet application running in Firefox or running in Chrome. That's like really common. So ClojureScript was a way to get into that ecosystem and stay relevant, basically stay relevant. But the nice thing about the parasitic approach is that the parasite, right? The parasite gets to have yes, we integrate tightly with the host, but we have our own ideas about things, and often these things can have side effects that are non-obvious. One of the most non-obvious things, which was probably obvious to if you were into functional reactive programming, yes, it was probably obvious to you. But if you weren't, one of the non-obvious things is that people are writing mostly purely functional code. So if I download some random library, it's by and large purely functional. What this meant is that it's a really great fit for live coding. So if you've ever seen Brett Victor talked about the fact that, what is this talk called? Shooting dead fish? Something like this. But it's all about, so much of programming is like, our brains have been completely eaten by sort of a batch-based approach to programming. You change your source and you recompile. And so in a browser, it's change your source, you refresh, go through all the state again to get back to where you were, right? It's this crazy, crazy long process. But if your code is mostly purely functional, you can actually hot replace only the code that changed, and you don't have to change the state of your application at all. And so there's a tool called Figwheel that supports this, and this is the thing that when people try ClojureScript, and they actually are like, okay, it's Lisp, it's crazy, but I'm just going to try it. And they try it, and they try Figwheel, and they're like, I don't want to go back. I don't want to go back, right? They have an environment which allows them to code on the fly, and the state of the application is preserved, and it's because all the code that they're using is mostly purely functional. It's what enables this. A lot of people like this. So Elm has the exact same property, which is another reason people really like Elm. And the other thing is that the mobile thing really just went crazy, right? Humans touching pieces of electronics with glass. That's just what humans do now, right? So it's important to work on these pieces of glass. So I was at the New York Times when they tried to write software for these types of computers, and it was painful, right? The type of applications that people write on iOS, it was like, okay, it's just like a menu and some buttons, and wasn't that sophisticated, but 9 months later, it still didn't work, right? This was typical. And the same is true for Android, right? There's this amazing new computing platform, but programming for it sucks. And you have to write the app twice, at least twice, probably 3 times for Android and at least 3 times for iOS, because each version is different. It's not that fun. So Facebook, I'm not exactly 100% sure why they did this, because it was a sort of a risky thing to do, but they came out with something called React Native, and it's been about 2 years, and it's really shown that there is a class of iOS and Android application which does not need the highest level of performance, for which React is a perfectly fine solution, and you can write it once. You can truly write it once and run it in a bunch of places, and that's really extremely powerful. So ClojureScript, right? There's this, like, anybody that's in the JavaScript space, right? Anybody that decided to start writing a JavaScript compiler 3 years ago is really happy, right? Because your thing just works. All this stuff that's happening in JavaScript, if your thing compiles to JavaScript, you can leverage it. And in fact, people do. So Mike Fikes is one of the big contributors to the React Native story in the ClojureScript world. And here he is. He's live coding against the simulator, but he actually helped write the code so that Figwheel, so this incremental thing that can hot load the code, works directly on the iPhone. So people that write React Native applications with ClojureScript, they get the Figwheel experience. So they get incremental updates while they're in their text editor. And also you have a REPL. So you have a socket REPL directly into the device. So you don't even need Xcode to do anything. You just bootstrap the thing, and you're just live coding your entire application. And this is an extremely popular thing to do. But what's the beauty of the system? Do we have to learn how to use React Native? React Native isn't our problem, right? That's somebody else's problem. We're just the little spider in the colony taking advantage of everything else that everybody else is doing. And then just a real quick note, this is just mostly, if you're into nerdy stuff. So about 1.5 years ago, we bootstrapped. So this is like meta, parasitic. We bootstrapped ClojureScript. So ClojureScript can actually compile itself. The compiler can compile itself into JavaScript. It can run inside of JavaScript without the JVM. And people have done really cool things with this. So this is ClojureScript running on iOS. So this is ClojureScript that's been self-compiled. And this is an app that runs on iOS, and it's a full-blown REPL. It does everything. Everything's there. The analysis, the compiler, it's all there. People have done even neater things with this. Mike Fikes did this thing called Plank, which is JavaScript core, which is available on Windows, Linux, and OS X. So we built an executable that includes the self-hosted compiler inside of the JavaScript core executable, and now he has a Clojure scripting language for every major platform, which is cool. And then there's another thing called Lumo, which is trying to do the same thing, but it does it with V8. V8 has this really neat feature, which is very Lispy, which you can do an image dump. So you can load your code into V8, and it all gets compiled, and then you can just dump the image. And then you have something that boots much more quickly. OK, so enough about ClojureScript. So almost done, actually. This was not a particularly long talk. But there are other things that are happening which are also, they're new, but new-ish, and I would say gaining traction. One of these things is Elixir. So Erlang was designed for building telecom switches, and it turned out that if you're in that space, then actually you're pretty good for distributed computing in general. And so they built a whole virtual machine for their language, and it turned out that the virtual machine was generic enough to host other languages. So Jose Valim, who was a contributor to Rails, he decided he wanted to make a new programming language. He picked Beam as the thing, his host, to host his parasitic language, and it's seen quite a bit of success because Erlang's really amazing technology, and all what Elixir's doing is bringing a modernized syntax and some nicer semantics. It's very cool. Something that I think is actually heavily in the spirit of when you're assessing these sort of parasitic programming languages, it's important to look at, are the language designers really serious about the host? How serious are they? And I think a huge inspiration in this vein is actually Fsharp. So, Microsoft made the common language runtime with the idea that, yeah, it's for C, it's mostly for C#, but if somebody wants to come along and make another programming language, they can. You have all these languages that run on the CLR. One of these is Fsharp, and Fsharp is a functional programming language of the ML family. But one of the most interesting decisions that they made, where a lot of the typed functional programming languages have this very strict barrier between the foreign thing and the code that you're writing, Fsharp says that's not really what devs want. I mean, what we're going to do, we're just going to pick the middle path. For the code that's all functional and here it's just this code and it's not interop, yeah, you can have very strong guarantees. But when you're interoping, we're just going to get out of the way, and there's not very strong guarantees, but it means that interacting with C# is a breeze. And Fsharp developers are some of the most enthusiastic people I've ever met, because what do they get to do? They get to leverage all of .NET. They're not pulling their hair out, and yet they get to use a very sophisticated typed functional programming language. So this goes back to what I'm saying. With a lot of these languages, there's a lot less risk than you would think, and all it takes is spending some time. Are they serious about the interop story? I would argue with languages like Scala and Clojure, that was like a design, right? A design goal. You have to work with Java. Nobody's going to care about your thing if you don't work with Java. And I think that a lot of these other technologies have also made that decision. So if you're looking for some new technology, you no longer have to reinvent the wheel. I think when you go out to assess alternatives, I think it's much easier to see that most people want to meet in the middle. They want to work on existing powerful platforms. There is an interesting thing coming in the near future. I think it remains to be seen whether it will be good or whether it will be problematic. So there's a thing called WebAssembly. It was originally called ASM.js, spearheaded by Mozilla, but it's definitely going to happen. Google's working on it. WebKit's working on it, and Firefox, of course, is working on it. And so it's basically, a type of bytecode which leverages the high-performance VMs. Currently, I would say the problem is that it's oriented around game development. So people that have existing C++ code bases, like a lot of the Firefox demos are Unreal. So they take the Unreal code base, they use a compiler to compile it from C++ into WebAssembly, and then they can call into WebGL, and then you basically have Unreal ported to the web browser. So it's really great currently for C++ code bases or game engines. It's a great fit. It remains to be seen whether the strategy is going to address the needs of languages like ClojureScript, which need GC, right? It's a bit strange, for example, if, I compile ClojureScript to WASM, and I have my own GC, even though there is a GC already in the browser. And maybe that's not a good idea. So I would say, it's a technology to watch. It has the potential to be something extremely important, extremely revolutionary, but it largely depends on whether the rest of the industry is convinced to add the additions that it needs to be a good fit for languages like ClojureScript or Elm. So we shall see. So that's all I had. I got done a bit early, but I'm happy to take questions.
I'll wait.
So
with these parasitic languages, like, whether you're targeting the JVM or the CLR or JavaScript, like, what do you think about places where design decisions are sort of forced on you as a consequence of that, right? Like if you're on the JVM, you don't get, tail call elimination. If you're, on JavaScript, you don't have multi-threads. Things like that actually really force you into corners sometimes. Like, I don't know what. I guess I don't have a coherent question about that, but like, spew your thoughts.
Yeah, no, I have thoughts. I mean, the thoughts are that it's the realism of choosing a host, right? It's like the fact the spider looks that way because it picked ants, right? Maybe it didn't really want to look that way, but too bad. Right? And it has these front legs. It has to use them as antenna, right? That's weird. So I think that you see this. Anything that's hosted on the JVM, you just see it. If you're a language, especially if you're a programming language geek, it's just like blindingly obvious. You're stuck with JVM decisions. If you do JavaScript, blindingly obvious that JavaScript is beneath it. So you're right. It definitely limits the possibilities. So that's, if I would say if WASM can address some of these concerns for implementation difficulty and integration into the browser, then that seems to me a promising place where you wouldn't be restricted in this way. So there is a possibility there, but I don't know because I don't know what's going to happen.
So WASM's like the LLVM approach, right?
Yeah.
I've heard some discussion about the idea of using Rust as a compilation target, and getting some of these host-like qualities that you described, some kind of an interop story with an existing ecosystem, but without the overhead of something like the JVM or even the Beam. So I'm just curious what your thoughts on that, if you think that's a reasonable approach.
I mean, Rust is cool. Rust went the way which I think I actually consider the Rust path to be riskier. In fact, Rust and Swift need corporate backing to be sustainable because you need to bootstrap that thing, and you need to spend millions of dollars on it, and you need to have a bunch of experts. And then at the end of the day, are people going to write software in that thing? Like that's the real question. Turned out, in the case of Swift, yeah, because Objective-C is not that fun. Rust, if you're in the C++ or C space, those things aren't that fun, so maybe Rust is the right fit. So I think you're right. Rust knows that it has to integrate with C and C++ and those libraries. So they're going to make whatever decisions and concessions they need to make that work.
I was actually, I appreciate that, and I agree with your statements about requiring the corporate backing and it being a risky approach. I've heard some discussion recently of people actually using Rust as the compilation target. So doing what you're describing, creating another language and compiling down to Rust to interop with Rust and kind of use it as an intermediate representation, basically. So
using it as an IR. I mean, I see. I'm sorry, I missed that. Using Rust as a source target, I mean, unfortunately, I'm not, since I've never used Rust, I can't say anything about what compiling Rust is like and whether that seems sound. Yeah, it's hard to say. I mean, I have no, since I haven't seen that. I mean, the thing is, for example, like with the JVM, you make a bunch of class files, it loads pretty fast, right? And we know it's fast to load, and it's that compilation thing isn't that costly. Same thing with JavaScript. You can parse 150,000 lines of JavaScript in like 100 milliseconds. So you know that you can generate a lot of JavaScript, and what's the big deal? I don't know if that's the case. I don't know if that's the case for Rust. Well, let's do.
I really like this idea where you say these are parasitic languages. They bound to a host, and perhaps they take something away. Maybe it's the user base. But have you thought about it in other terms as well as being maybe symbiotic languages? Do you think about some of the things that they maybe contribute back to the community? For example, the way Clojure may contribute back to the JVM community in some way.
So I would say that Clojure probably hasn't had that much impact on Java or the JVM itself. Unfortunately, it really took Nashorn for Oracle to get off its ass and do something about invoke dynamic. But ClojureScript is slightly different because JavaScript is, for how big it is, JavaScript is a bizarre world, right? It like literally changes every 6 months. So they're more open to ideas for some weird reason that's hard to discern. But there has been some feedback, like from Elm and from ClojureScript back through React, actually. So that there's been a lot of cross-pollination there, which I'd never expected to happen. So yeah, it's definitely, I mean, I was surprised that I would have said no way. It's like we take, but we can't really give back. But I would say ClojureScript and Elm have shown actually information can flow in both directions.
So in terms of the characterization of these languages as parasitic, I guess my question is, what does it take to be a successful parasite? So for you mentioned a bunch of languages that are doing relatively well, but I can think of some parasitic languages that maybe, I don't want to say they're doing badly, but from my perspective, they're probably doing less well. Like I don't think Dart is necessarily doing that great, or like there's like Gosu and Ceylon and a whole bunch of these like sort of Java-like languages that are like adding a little bit, but maybe they're just not enough to really get people to switch to them. Like, what's your perspective on like, being somewhat compatible seems like an advantage, but being too compatible seems like maybe there's not enough of a compelling reason to use it? I mean, what's your take there?
Well, so Dart is particularly interesting because actually I would say Dart was not parasitic, right? Dart was like, let's start over. I mean, Dart was a new VM technology. They built their own custom ID on top of Eclipse to handle it. I mean, it just seemed like, okay, you really want to like do small talk over again, and it's commendable. I think it's cool. Of course, I think it's cool. But does anybody else think it's cool? I don't know. And actually, with Dart, there was, they sort of, to a large degree, they deprioritized the VM stuff for the Dart 2.js compiler, right? So that's. So it's interesting that more effort was put into the parasitic thing than the, let's build our own new reality. You're right that, of course, there are failed experiments on the JVM. They came and they went on it. I feel like if you looked back, I mean, that may, to a large degree, did it offer enough over Java to be worth it? Like, I think Scala was great. Scala positioned itself that way. It did something that Java wasn't going to do. I mean, it looked friendly, and it could be just like Java if you want, but it really was offering something new.
Kind of two questions. The first one is, so like the languages that you put up there, I kind of see them on a spectrum. On one side, you will have like CoffeeScript and TypeScript, which are kind of incremental, and then on the other side, you have ClojureScript and Elm, which are like these large leaps. I'd be curious, like what are there popular packages that we're using that we don't realize are in these kind of the languages more like ClojureScript and Elm that are different that we might not be realizing that we're using?
So Elm is a little bit different in that they now have, I think, a decent, they're improving their interop story a bit. But Elm does require more effort in sort of recreating, it requires duplication of effort because the FFI there's more friction than there is in ClojureScript. So you see people often taking a JavaScript library and rewriting it. So, and I'm not that familiar with Elm, so I can't say much more than that. With ClojureScript, though, we continue to push in the direction where it's like you can use Google Clojure, which a lot of people don't use Google Clojure, but we have perfect integration with Google Clojure, which is like 300,000 lines of JavaScript of reusable stuff. And then we also, we're just now pushing into making it possible to include NPM dependencies into your build. So you can mix dependencies that you pull from Maven and NPM into one thing. So the idea is that we want you to be able to use whatever is out there. So it's not about like, is there something in ClojureScript that we do that's special? It's more often than not, we don't want to reinvent the wheel, so why don't we make our compilation process accept the ecosystem?
Sure. Are there examples of going the other direction where like as a JavaScript developer might not realize they're using a ClojureScript package?
So that's not true because, so this is, I mean, this is sort of outside the bounds of the talk, but I can explain quickly, is that ClojureScript relies on Google Clojure Compiler, which is a Google JavaScript compilation technology, and it's a whole program optimization. So the way that it works is it takes all your source files, and then it creates, walks the entire call graph to figure out what you actually need, and then produces the final artifact, which you're going to, deploy. But it's a whole program. But that means that, as a general rule, the thing that you end up with is not small. It's something that's fine for a website, but it's not great as a library. So you don't see people using ClojureScript without knowing about it.
Another somewhat related question. You mentioned things coming from Elm and ClojureScript back into JavaScript rather than the other direction. Could you talk more about that?
So, for example, I mean, one of the things, so CSP started getting pretty hot, communicating sequential processes, because that's, Go is very popular. So people are familiar with that now. It's not weird. But Clojure also did it, and it did it for both ClojureScript and Clojure at the same time. And this was really before yield had really was like a reliable thing. So we started talking about CSP, and then shortly thereafter, people were experimenting with the CSP model in JavaScript, and that was interesting. More recently, there's a thing called spec, right, which is our sort of property-based testing plus sort of specification, which is really cool. And Alex Miller, who's here, he's going to talk about it tomorrow. If you haven't heard about Clojure spec, I highly recommend it. And I gave a talk about that in Vienna to a very large React and JavaScript meetup, and there was some interest there. People were very interested in yeah, we don't like types, but we would like to have some form of specification, and they liked what we were showing. So I would be very surprised if you don't see something like that also appear. Oh, there is. Okay. Okay. Well, there you go. Then I wasn't following it, so it already exists. Yeah.
I'm just going to keep asking questions until someone else volunteers. So on the subject of ClojureScript, right, and this sort of path of taking a language which was parasitic on the JVM and sort of moving it to JavaScript at the same time, right? Scala.js is a thing.
Yeah.
And ClojureScript is sort of a lot further down that evolutionary curve than Scala.js is. I mean, you guys have been at it for a lot longer. So what sort of bumps in the road do you foresee for something along that process, right? Things like getting the ecosystem to go along, different trade-offs that you have to make in compilation. You're just sort of again, more thought spewing. What do you think is cool?
Yeah, so I think Scala.js is really great. I've had multiple conversations with the person who leads that project, Sebastian, and I actually think that he is very well aware of ClojureScript, and we've talked about it. They've chosen the same strategy. They whole program optimization. So their system is actually much nicer because they actually have a first pass using the Scala, right, to do a lot of more dead code elimination than we actually currently do, and then finally Google Clojure gets to it. And so that's really, really cool. They have a lot of optimizations that aren't possible because their optimizations are type directed, and we can't do that stuff. Super cool. But for the most part, I've seen Scala more or less trace a lot of our footsteps with the big decisions. Google Clojure being one of those, but also React. From what I can tell, the React integration story for Scala.js is just as good as the one for ClojureScript. And I think it's really cool. I mean, I think that Scala.js rounds out that story for the Scala world. I think Sebastian has been I want the experience of Scala.js to be more or less the experience of Scala. And I think that's what we've tried to do with ClojureScript as much as possible. And so I think that completely on the right track. Other questions? Cool, thanks.